Hello, dear students. Let's see this question number 3.8 of IE Irodov. The question states a thin half ring of radius r is equal to 20 centimeter is uniformly charged with a total charge q is equal to 0.70 nanocoulomb. Find the magnitude of the electric field strength of the curvature center of this half ring. This is a very easy question for those who are preparing for IIT-JEE or other engineering exams. At the IIT-JEE level, we have to use the direct result of the formula, and that result is 2k lambda by r. So here the problem is given, so the purpose of the problem is to arrive to that result. So in other words, I'll be giving the proof of the result of the electric field due to a semicircular ring at its center, and the numerical value I'll not obtain. I'll just arrive to the derivation that E is equal to 2k lambda by r. So let's proceed. So this is a half ring of a uniform distributed charge whose linear charge density is lambda, radius is r, and we have to find electric field at center. So what we can do, we can take some element. I can take an element here, which is at angular position theta from x-axis, and let's take a little element of the ring. That little element is subtending angle. This little element I am taking, this little element of the ring is subtending angle d theta at the center. So the length of this little part is r d theta, the radius is r. So the charge of this little part q is equal to lambda into r d theta. Lambda is the charge per unit length, that is the linear charge density. So because of this little tiny charge would be acting as a point charge, so electric field at the center would be obviously at a line along this line radially away from that point charge. So suppose that electric field is dE. So we can write dE is equal to k dq, and that dq is lambda r d theta, and divided by distance square, that is r square. So dE is equal to k lambda by r d theta. This electric field will have some component along this direction and some component along this direction, and this component is dE sine theta, and this component is dE cos theta. And if we look symmetry of this problem, so all those components along x-axis will get cancelled, because if I go symmetrically at this point, and because of that element, electric field will be along this direction, so its y component would be along this direction, x component will be along this direction. So these two components, the pair, all the elements which are symmetrically to say y-axis, those components, x, those elements, x component would get cancelled. So what we will remain with the electric field only due to the y components. So the y component of electric field will get add up, and the x component will all cancel each other. So the y component is dE sine theta. So I can write the net electric field at the center is the sum of all those components along y direction, that is the dE sine theta. And here that is a k lambda by r sine theta d theta. And from where to where we have to take theta so that all the elements are covered. So we have to take theta from 0 to pi, and the integration of sine theta from 0 to pi is 2. So we'll get the result 2k lambda by r. And if you want to write this in terms of q and r, so I can write first of all 2k 1 upon 4 pi epsilon naught r, and lambda is the charge upon length. The length of this wire is pi r, and the denominator there is one more r. So now in terms of q and r, we can write this is a q upon 2 pi square epsilon naught r square, and this is the magnitude of electric field, and this net electric field would be along this direction. And that is our answer. Thank you.